So according to Dalton's law of partial pressures, if we have a mixture of gases with different identities, say P1, P2, and P3, the total pressure of the mixture of gases will be equal to the sum of the partial pressures of each individual gas. So let's say we're in a situation where we know the total number of moles and the number of moles of each individual gases, but we don't know the pressure. What we can do then is then sum together the number of each individual gas's moles. So the moles of gas 1, N1, N of gas 2, and N of gas 3, we can sum them together to get the N total. And then what we can do is you can plug the total number of moles to solve for the pressure of the total mixture of gases. So we can rearrange the ideal gas equation, and we can use the total number of moles to solve for the total pressure of the mixture. You'll notice here that volume doesn't have a subscript, and that's because gases will expand to take the shape and volume of their container, so all of our individual gases will have the same volume. So now that we've solved for our P mix, let's say we want to solve for the partial pressure of our individual gas, of the partial pressure of gas 1. How could we go about solving that? So if we know the number of moles contained in gas 1, we can use this to solve for the partial pressure of gas 1. So the way we would do this is we would rearrange the ideal gas equation, and the partial pressure of gas 1, or N1, would be equal to the moles of gas 1 times the gas constant times the temperature divided by the volume. Again, we'll see here that volume and temperature are the same for all of the gas because the temperature is the same, but also because all of our gases will occupy the same volume. And so we can use our moles to solve for our partial pressure of gas 1. We can plug it back into our equation to then solve either for the P mix, or if we know the P mix, to solve for a pressure of a different gas. We could also repeat this with gas 2 to find the partial pressure for gas 2, or with the moles of gas 3 to find the partial pressure of gas 3. So another way that we could go about finding the partial pressure that doesn't involve using the ideal gas equation, but if we know all of the moles of our different components in our mixture, is we can use something called the mole fraction. So let's say we're in a situation where we know the number of moles of the individual gases and the total moles. We also happen to know the total pressure. We can use the mole ratio to solve for this. What we can do is we could take the moles of our individual gas, in this case gas 1, divided by the total number of moles, and this would give us the mole fraction. So once we have the mole fraction, we would multiply the mole fraction by our total pressure, and that would give us, and that would be another way of getting us to the partial pressure of gas 1. So you can see here we have two ways of interconverting between moles of a gas, an individual gas, and the partial pressure of an individual gas using the relationship between the mole ratio, the individual pressures in moles, and the total pressure in moles.